Welcome to MRU E-Learning powered by Malla Reddy University. I am Mr. S. Navin Kumar, working as Assistant Professor in Department of Computer Science Engineering. So today my topic is software quality testing. So the contents are like this. So initially I want to start up with a question to students, and then I want to talk about software quality and key aspects, importance of software quality in SDLC, cost of quality and categories of cost of quality. So let's start with a question like this. So if some student is given a software and asked it to use, then if the question is like this: if software works today but fails tomorrow, can we call it a software quality? So this question sets the context of the discussion of whether quality is important or the functionality is important. So this subject will be talking about the importance of each and every factor, and does not degrade any feature like functionality, but also upgrades the feature like quality. So why actually quality is important here? Why? Because today we are seeing software usage in each and every field. So I have listed out here some important domains that are seen in the day-to-day life. The first one is called as banking sector. The second one is called as healthcare sector, aviation sector and education sector. And if we are not maintaining quality to the mark, and if at all we are not giving the expected quality, sometimes there will be huge financial loss and even the loss of life. So after completing the introduction, let's go with the definition of software quality. So software quality is the degree to which a software product meets the specific requirements and user expectations. So here we are going with two things here. So before developing a software, we will be listing out what are the exact requirements of the client. And after developing the software, we will be talking about the user feedback, user fulfillment. So here, if these two things are being fulfilled, then definitely we can say that software quality is achieved. So this is one type of definition. So some other has given some other definition like this: the totality of features and characteristics of a software product that bear on its ability to satisfy stated or implied needs. So all in one way or the other way, suggesting that first of all we are listing out the requirements. The second thing is we are listing out the user feedback. So if these two things are achieved, then you can say that software quality is achieved. So in simple words, in order to a student to understand this, software quality can be defined as doing the right thing and doing it in the right way. So now there are some features which will measure exactly what is software quality. Software quality is measured through attributes such as functionality, reliability, usability, efficiency, maintainability, and security. And let us take a real world example, like in our day-to-day activities, whether you are in a personal life or in a professional life, you are using the WhatsApp to a maximum, and sometimes communication these days often done using WhatsApp application. And here WhatsApp application, if at all you talk, so you can talk about all the listed out features in the last slide are achieved here. It works correctly. Whenever you are sending a message, it will receive by the recipient. So functionality, the motto is achieved. Ease to use. So WhatsApp is a type of application where you are seeing day-to-day new features, and we are able to engage users by using the new features here. So usability is achieved. So fast message delivery. So immediately when you send a message, within no time the receiver will receive a message, and that is known using the color tick combination, and that is called as efficiency. And from the starting onwards, the WhatsApp application is stating that we are using end-to-end encryption, and we are giving top priority to the user security. And here in this way, security is achieved. So these are the things achieved, and this is the reason why users are increasingly using the WhatsApp in the day-to-day life. So now, on a whole, we can say that software quality is not tested at the end. So it should be tested in each phase of development, And now we have to get an idea of what are the phases available in the software development. So here we have to understand that whenever you want to develop a software to the maximum quality, so you have to understand how the SDLC work. So SDLC stands for Software Development Lifecycle and have these certain phases. Requirement analysis is one, design is one, development is one, testing is one, deployment is one, and maintenance is one. So let us achieve some knowledge by knowing in each phase how this software quality matters. So now if at all you talk about requirement phase, so quality focus should be in such a way that the requirements, whatever we are mentioning in the SRS document, should be clear, should be complete, and should be correct. So if these three things are in proper place, then you can say that at the requirement phase we have achieved the quality. And if these three things are ignored, such as the requirements are not clear, the requirements are not complete, and the requirements are not correct, then there should be some problems like requirements are misunderstood. Why? Because we have a large team of software development where hundreds and thousands of people are involved. So any miscommunication between those teams will lead to the software low quality. And if these are ignored, like clear requirements list is ignored, complete list of requirements is ignored, or correct list of requirements are ignored, then the software what we developed is not the software what we are expecting. So here I have taken an example here, like clients want online payment and developer builds cash and delivery only. So this is one example where what is actually to be developed and what is actually the user is expecting. So here you have to understand the importance of quality. So now once this phase is done, we are going to second phase where again quality matters. So design phase is one where you have to build up proper architecture, you have to go with proper modular design, and you have to go with scalability. And architecture is a flow where you understand what you're doing, and if at all you are in the middle of the project also, you can able to understand what you're doing. And modular design is like dividing a huge project into small parts so that everything can be done parallelly and integrated within the given stipulated time. And scalability is about how you are managing the things in the given parameter list. And once these three things are properly maintained, you are said that in the design phase also you are maintaining quality. And if these quality factors like proper architecture, modular design, and scalability are ignored, then what happens is like we are going to see the poor performance of the software, and we are going to have a difficult maintenance in the future when customer is trying to use it. And if this is the process, then an example is like this, like monolithic design is always a bad design. Why? Because in the future you may not able to add new features here. So once this is done, we are going to next phase where we are understanding what is the importance of quality, called as development phase. So here we are talking about how we are maintaining the coding standards, how we are doing the coding reviews, and how an error is handled. And if these three things are in a proper place, then you are said the quality is maintained. And here if these three are not maintained properly, what happens? Problems we face is unexpected bugs and security loopholes will be in place, and we may not solve them in a proper way. And here an example can be hard-coded passwords can be a route for security breaches. And once this is done, we are going to next phase called as testing phase, where we have to maintain proper measure of how you are detecting the defect and how you are validating and how you are verifying the standards, the coding, the design, and everything. So if these two things are properly maintained, you are saying that quality is maintained in the testing phase also. And if these two things called as defect detection and validation and verification are not properly maintained, then software crashes in the production are the problems that we are going to face. And an example can be taken like app crashes during peak times due to the untested load conditions. So I can take many examples here. if you are not properly verifying the things in place, then you are going to face all these type of problems. And once we are done with this, we are going into the next one called as deployment phase, where the quality should be focusing on smooth installation and compatibility. So many of the softwares are developed in one operating system and should be deployed in any other operating system. So this is called as compatibility. So if these two things are maintained properly, then we can say that you are maintaining quality at the deployment phase. And if these two things are ignored, then customer may be having some dissatisfaction while using the application. So once this is done, we are going to the last phase called as maintenance phase, where the quality is measured by easy bug fixing and adaptability. So here these two things are to be maintained properly, and once we are done with this, then we can say that in each and every phase of the software development lifecycle, we are going to maintain the quality, and we are going to give the proper product which is having a quality and which is having a user satisfaction to the maximum. And you have to understand that 70% of the software cost is spent in maintenance if these things are not properly maintained. So once we are done with this, this is the small table for a glance, quick glance of what each phase is doing and what it is, what its role is. So if you are talking about requirements, correct needs are to be measured. If at all you are talking about design, stable architecture should be designed. If at all you are talking about development, bug-free code should be written. If at all you are talking about testing, defect-free software should be derived, or we have to remove the defects identified. If at all you are talking about deployment, then you have to talk about user satisfaction levels. And if at all you are talking about maintenance, then you are talking about the dependence of the software product by the customer. So now, as a whole, we can say that software quality is not a phase, it is a continuous process across SDLC. So from starting A to ending Z, we are talking about quality. If in each phase, in each line of code, if at all you are maintaining quality, then ultimate result will be a quality product. So the second one is cost of quality. Now, till now, what we have discussed is like we have to maintain quality. We have to maintain quality. And in each and every phase, we have to maintain quality by understanding what is the importance of quality maintenance. Now, let us discuss about what is the cost we have to incur when we are talking about quality. So everyone wants a quality software, but is it really possible? And if at all it is possible, at what cost? So this is the thing here. So cost of quality is the next topic that we are going to discuss. So cost of quality is the total cost incurred to ensure software quality and cost due to the poor quality. So this here, the ensuring the software quality is in the hands of the development team, and cost due to the poor quality is due to the maintenance done by the user. So if this is properly done, then this will be minimized. This is maximized means this is minimized. So this is how you have to understand. So now see here. Now we are talking about categories of cost of quality. The first one is called as prevention cost. So here, if at all you are investing money in avoiding the defects, then the product will be having some unnecessary removal of the cost here. So cost to avoid defects will be talking about unnecessary training developments, process improvement, and quality planning. So training developers on security coding is one type of example you can take here. So you can avoid this. This type of cost is not mandatory. So here companies are talking about people who are already knowing the knowledge. Today any company is not talking about taking a student into a company and then training. They want a student who is already trained. So here training process is a cost cutting. Okay, one. Next one is appraisal cost. So here cost to detect the defects. So this is the second type of cost here, which includes testing, which includes code reviews, which include inspections. So here testing the software code is okay. Coding reviews done are okay. Inspections to be done are okay. But to be done only in the limited sense. So testing, we have told that testing should be done. We have told that testing should be done. But that does not sense that you continuously keep on doing testing. So inspections are to be done only once or only twice or only in the limited number. So somebody has told the team that inspections should be done on day-to-day basis or on monthly basis. So it's not meant that you have to go on with inspections every time. So by decreasing this number of testing times or number of inspections, you can say that you can decrease the cost of appraisal, and this is one type of thing. And here, while you are talking about testing, you are talking about two types of testing here. One is called as manual testing and one is called as automation testing. So the next one is internal failure testing, and this type of testing cost can be decreased when we found defect before delivery. So includes rework or debugging or retesting. So rework should be done in such a way that only once or twice. So you cannot do it again and again and don't waste money of the company or the stakeholder. Debugging also can be done, but only in the limited sense, and retesting can be done only in the limited sense. So here fixing bugs found during the system testing is one type of internal failure cost. So if at all you are maintaining proper quality, this type of cost will be reduced. And this is the external failure cost. And this is the type of cost we are incurring when we found a defect after delivering the product to the customer. So here, customer may give a complaint like device is not working, warranty claims are sometimes, so low loss of reputation. So all these type of things are coming into the scene only if you are not maintaining proper quality. So bank application failure, that means customer will be losing some money in one way or the other way. So these are the different type of costs that we can reduce. And if at all you are maintaining proper quality, so to ensure software quality and to decrease this, to minimize this cost due to poor quality, you have to do these things. The first one is prevention cost. The second one is appraisal cost. The third one is internal failure cost. The fourth one is external failure cost. So external failure cost is said to be the heaviest cost that we are going to bear. Why? Because we have to satisfy the customer from beginning again. So here you have to minimize. You can minimize these things while maintaining proper quality. Now, the last point here in quality is quality cost distribution insight. So prevention plus approval will be the investment. Okay. And failure cost will be the losses. So this is the equation you have to understand. And golden rule is that it is cheaper to prevent defects than to fix them after release. So prevention is better than cure. The simple words. So now the real-time example is this. Real-time example, industry example is NASA software failure we have seen in the past, where we have seen a loss of almost $125 million. Okay. So lowest cost is to prevent it by identifying it before the delivery, and highest cost of quality is we are identifying the delivery after the delivery, identifying the defect after the delivery. So the key takeaways, what are the things you have understood here is software quality ensures customer satisfaction. You understand that if there is no customer, there is no software. So customer satisfaction is the first and the foremost thing you have to understand. Then quality must be integrated into every SDLC. So you develop a small application or you develop a huge application of crores of rupees. The only primary principle is that you have to maintain software development lifecycle phases in a proper manner. So cost of quality helps organizations balance investment and losses. So see here. Now I am not telling that every company is seeing losses or every company is seeing profits. Every company will see both. They will be seeing the losses, they will be seeing the profits. So if at all you are properly investing money, you can minimize the losses. That is the point here you have to understand. Like quality of the cost helps organizations balance the investment and losses, and early quality saves money, time and reputation. So phase by phase implementation of quality, while we are talking about development of any software, by using SDLC, then early quality will maintain and saving money, time and reputation. Now, some standards are there here which will be telling you about how you maintain quality, on what basis you are telling that quality is maintained. So here I have come up with 3 persons who have brought some quality standards, established some quality standards. So I'll be listing out them. The first one is called as McCall software quality. Jim McCall was a person who proposed this quality model to bridge the gap between the user and development in evaluating the software quality. So he is telling that there should be a proper understanding between the users and developers. So he identifies 11 models here. He identifies the 11 quality factors here, grouped under product operation, product division, and product transmission. So here let us understand, and he highlights how well software develops, how well the software performs, how well the software delivers, how well the software satisfies the user needs. Okay, how well the product will be adapted to a new environments. So these are the list of features, factors. So the first one is called as product operation factors. So this will tell that how the software runs. So correctness is one, which is the way you understand how the software meets the specified requirements. Then readiness is one, which will be having the ability to perform without failure for a given time. And efficiency is the next one, where we are trying to use maximum resources such as CPU, memory, and time. Integrity is one where you are talking about protecting the quality, protecting the software, protecting the user data against the unauthorized access or data corruption. And usability is one more factor which will be helping us to understand the software properly. So all these comes under the concept called as how software runs. The next one is how easy it is to be used. It can be changed. So maintainability is one which, if at all we have developed a product and we have sold it, and one customer is using it, and maintainability is a problem here. So if this is properly done, then you can make changes easily, or you can fix the defects easily. This is one feature. The second feature is ease of modifying software for new requirements. Suppose you have launched a software product with some 5 to 6 features, and it has done 2 to 3 years back, and now you want to launch or relaunch, or you want to update the device or software with the new features, then it should be easily done, and this is called as flexibility. And testability is the way of how you are testing the software to see the correctness or the reliability of the application. So all these will come under the product division factors, and it will make you understand how easy it is to change. And the last one is how easy it is to move. So now it happens like in the earlier days we are developing an application using a computer, but it can be launched in any type of device. So it should be able to portable in different environments. So we have different type of environments here. Single user, single tasking environment is there. Single user, multitasking environment is there. Single user, multi-user, multitasking environment is there. So whether you develop application or software in any type of environment, it should be able to be working in any type of environment. So this is called as portability and reusability. So ability to reuse components in other applications. So it should be working as a reference to the future applications. Why? Because sometimes we are seeing the clone applications where the existing features are mostly copied into the newly developed feature, newly developed device or software. And interoperability is one more factor, and it is the ability to interact with other systems or software. So these are the 3 factors which you have to concentrate to understand how easy it is to move, and this is called as product transition factors. So now once we are done with this McCall's quality factors, we are going to the second type of quality model called as Boehm's quality model. So Barry Boehm is one person introduced this standard to define software quality. Whether he want to know whether this software is developed in a structured manner and hierarchical model, and whether the quality is maintained or not. So model identifies 3 high level characteristics. So if at all Boehm is telling that if you maintain 3 factors here, the first is as is usability, the second one is maintainability, the third one is portability, you can say that quality is maintained. So it is somewhat different from the earlier McCall's quality model, where you have to address 11 factors to identify the quality. But here you are talking about 3 things. One is called as is usability. The second one is called as maintainability. The third one is called as portability. And based upon these 3 features, you can say that quality is whether maintained or not. So each high level characteristic is broken into intermediate and primitive objectives. And Boyens model is useful during the design phase to predict and improve the software quality. The ultimate target is to develop a software in such a way that quality is okay, quality is accepted. And the last one and the standard that we are maintaining in India is CMMI model, capability, maturity, model integration. So CMMI Institute developed this model to improve and standardize software development process in organizations. So here in India, if at all you want to launch any software application, if at all you want to launch any product, then you have to take the approval from this institute called as CMMI Institute, where it will try to improve and standardize the software development. And this has defined 5 levels here. Initial, managed, defined, quantitatively managed, and optimizing. So these are the 5 maturity levels that were defined by CMMI, and based upon the rating, you are going to get any one of this stage, and based upon that only you can decide the cost of the product. So each level represents a stage of process improvement and organizational maturity. The model focuses on process quality rather than individual product features. CMMI helps organizations deliver consistent, reliable, and high quality software through continuous improvement of the process. So these are all about the things that we have discussed. So here, so this is the one thing. Quality is not a phase, it is a continuation process across the SDLC. This is one thing you have to identify. The next one is quality is not tested at the end, but it is built throughout the development process. So this is all about for today's class. We'll talk about more on the subject in the coming classes. Thank you.